so let's get straight to it. So if you're in the web scraping industry, you know this never-ending war between bot and anti-bot. So today, we will see who's actually winning in 2025. So first, we are going to explore two major areas. First, we will talk about the anti-bot part, so IP address, network fingerprint, CAPTCHA, etc. Second, we will see how AI is transforming the way we write and maintain scrapers. So first up, the network fingerprint. So fingerprints are easy to detect, hard to mimic. So let me break down that layer by layers. So on detection side, it's almost too easy, to be honest. You can grab information from the IP address using GeoIP database, free or commercials. You can check IP reputation score. You can analyze TCP, UDP pattern. You can inspect TLS handshake. You can examine HTTP2 headers, whatever. There is a lot of things that you can find, scan. So there are tons of open source libraries that make detection straightforward. But on the emulation side, it's completely different. Let's start with IP address. So this one is not really a problem. You've got cheap IP address, residential proxy. So now getting IP address, very clean ones, is not an issue. But for TCP, it can be really technical with TCP and UDP stack. So if you want to spoof the UDP and TCP information, you need to write complex kernel level code. I'm speaking about kernel package mangling, so you need deep C++ knowledge, you need serious skill in terms of programming, system programming. So it's not impossible, but clearly it requires a lot of expertise. So then let's talk about TLS layers, so the encryption layers. So detection is really easy with the J4 fingerprint. Currently, we have a lot of commercial tools, including it, so they will give you the fingerprint on the J4 fingerprints. But if you want to emulate it, that's another story. So there are very few good open source tools on the market, and those tools, you know them, they provide you only very few profiles, so they already are recognized by anti-bot systems. And it's pretty much the same story for HTTP2, HTTP3. So to summarize, detecting network fingerprint is really easy, but emulating them requires expertise. So this time, point goes to the anti-bots. Good for you? Yeah. So now let's talk about browsers. So many years ago, we saw anti-bot system executing JavaScript to collect thousands, no, let's say hundreds of signals. On the bot side, we have also exciting innovations in the open source field. So you might have heard about Camufox. Who know Camufox? I hope a lot of you. So if you know, if you don't, so you should have. And let's say thanks to Jero, thanks bro, to create this one. So Camufox is a modified version of Firefox. And it's way more powerful than using Playwright, Puppeteer, or Steels extensions. So what makes it special? Jero modifies Firefox at the C++ level, which means you can directly modify fingerprint on the browser code without being detected. So you can change whatever you want, canvas fingerprint, WebGL signature, audio context, fonts, that's nice. But here is a catch. Because it's open source, of course, anti-bots have already analyzed Camufox signatures. Antoine confirmed this morning. So what's the ultimate solutions? Building your own custom browsers. And this is the serious thing that serious players are doing in this industry. So, but let's be real. So if you want to do that, you need a bunch of experts to understand Chrome source code, network protocol, hardware interactions. That's really kind of complex stuff. And that kind of skills is really, really expensive. So you say, okay, let's do that with GenAI. Let's modify the code of Chrome. It's not working. it's not able to handle the whole context of the source code of Chrome, even you are providing subcontext. So that can be difficult. And on the antibot side, we saw new advanced techniques. You probably heard about WebGL fingerprints, so you draw shapes, text, emoji with different fonts on a hidden canvas, and you can get the unique rendering signatures. Now we have audio fingerprints. So the concept is really similar. They send oscillator signals through your audio context, and you analyze the output, and each hardware produces a different signatures. But to be honest, you have to really test this one. But things are getting more exciting with GenAI. So let me show you some things. I'm going to take an obfuscated antibot code and drop it to Claude 4.5 UIs. And it's try to deobfuscate and refuse. Yeah, on the latest models, they've implemented restrictions. But those restrictions don't exist everywhere, of course. So I'm using Windsurf either with the same Claude Sonnet code with a different prompt. And I dropped the source code, and the model started analyzing, and it gave me really quickly, I've got obfuscation techniques, fingerprint signals, behavior analysis, bot detections, and detecting reverse engineering. So this kind of work would have taken me 3 months by the past. And what you can understand, I can do that in 15 minutes now. So in 1 week, you could analyze every antibot solution on the market and create a competitive analysis. That's a complete game changer. That's nice. Yeah. So yeah, let's summarize. We have incredible reverse engineering capacity. But due to the complexity of developing a custom browsers, the point go to antibot. Okay, let's continue. So let's talk about CAPTCHA. We love CAPTCHA. So today, if you implement correctly your CAPTCHA solvers, so you bind your LLM, your AI models with really nice automation stack, so you emulating all the signals, you can bypass CAPTCHA. So what can antibot do? So I see some pretty excellent measures. So here, some sites are now asking the user to turn on their webcam, so it's Google proof of concept, and they wave their hand to prove that you're a human. LLM cannot do that yet. But think about the experience. Imagine that you're buying something on an e-commerce website, you're ready to pay, and suddenly they ask you to start your camera and wave your hand before payment. No, that's not a good experience. You just switch to a competitor. So, yes, that's not very, very good. So let's move to the research part. I saw some really, really interesting parts on the research part. So it's a presentation from Elisa Ceponi and Martinez Biozis about detecting CAPTCHA forms. So how can they do that? So it's experimentations. Their approach is really, really clever. They analyze the timing of the patterns when you implement CAPTCHA, and when you're using that for solving. So when you integrate the CAPTCHA forms, you'll send the CAPTCHA to the service, you wait for processing, receiving the solution, and post back to the service, to the website. And if you carefully analyze the timing of the sequences, you can detect if you're using a CAPTCHA form or not. So for this round, I think point go to the bot. Perfect. So now let's talk about something really, really important in our industry, scraping maintenance. Who struggle with maintenance? You can raise everyone your hand, otherwise you're a liar. Yeah. So this is where the AI is making the biggest impact in your industry. So here is a problem. So websites evolve constantly. So they change their design, they update their CSS classes, they restructure the HTML, and every time it happens, you have to analyze, understand where the problem is, and perhaps to rewrite everything. So it's nightmares. But it's getting worse. We've got A/B testing. Yeah, they have different versions of the websites. So they might serve one version to regular user, another to suspicious user, another for geolocations, and they combine everything. So you could have 3, 4, 5 versions for the same website. So imagine that you want to create a spiders for the travel industry. So you enter the date, you select the different passengers, and you navigate on the multi-step checkouts. Okay, you get the price. But now you multiply that by multiple versions, multiple targets, and it's become a maintenance nightmare. And that's where GenAI is really, really cool. What you can do. So first, the first idea. So we will use this example website. So it's a greyhound racing website. So if you're looking for greyhound racing, just 20 minutes away, you've got whole result here. You've got time, winners, prices, distance. Quite cool. So let's collect data from this website. First idea that I will do is direct extractions. So idea is really simple. You take the HTML, sometimes you can use some screenshots, and you just drop that to the LLM to get some JSON models, JSON formats. So let's do that with Claude. So I'm dropping here the HTML, and I'm also dropping a prompt and asking to extract from structured informations. So it's working, and I've got my good data here. The quality is really excellent. But the thing is that you don't know, is it took me 5 minutes. 5 minutes just for one page. So even the quality is excellent. So the speed and the cost of using the LLM is really unusable. So what I will do is do another things. I will take a different approach. Instead, I will ask to the LLM model to extract, instead of extracting the data directly, I will ask to create a spider, to generate ones. So I will give the HTML, some screenshot of the page, and he will write a spiders. So you can do that with the web scraping copilot extension presented this morning. That's cool stuff. By the way, it's really brilliant. So let me show you, I will do that only with Claude. So what I will do, I've got here scrappy in Windsurf. It's an empty spiders. I've saved the HTML and screenshots of the meeting list and also the meeting details. Now I'm dropping a prompt and asking to extract the list of meeting and extract each information from the meeting cards. I'm also very important, including the screenshots, so we can understand the visual structure of the item.py. So now he's reading everything, creating the extraction structures. So you will see we'll get the item.py. So I've got everything here. And the LLM will understand how to write the spider using the right selector, XPath, CSS, and whatever needed, regular expressions, and run the spider. So he runs the spiders, and he's got all the results. So that's perfect. So you see, you can write the spiders in minutes. That's really quick to do that. But here is the reality. You probably have already code written by your team, and you don't want to put all this code to the trash and restart every time the website changes. So what do? So I've developed an MCP server called the Scrapy Inspectors. So it connects to the LLMs, and first it will inject a middleware to record all the requests and response, also headers and body contents. So second, he will let the HTML execute code against those responses. So testing CSS selector, XPath expression, regex pattern, and without rerun the full spiders. So the LLM starts the spider, check if it's working, analyze the request and response, and when it fails, tries modification and iterates until the spider is fixed. So let's try that. So I'm starting the spider, it fails directly because the website changed. So they modify some CSS classes on the website and deleted the colon from the race card table. So now I'm giving a quick prompt, which is fix the spider using exclusively the MCP scraping inspectors. So I'm dropping this prompt, and first the spider has to, the LLM has some guidelines. So I'm giving guidelines because fixing a spider is not an easy task, and it will inject automatically on your existing code the middlewares. So we see, he understands, so the spider is executed, and we get the list of requests, and we understand there is no response. So he's analyzing the different requests, executing some code to find the first issue. So now he made the first corrections and checking if there is more requests. So yes, we have more requests here. But there is still an issue. The issue is, indices are shift by 1, but the spider doesn't know. So we have to check on the code automatically and to understand what the error is. So now he's trying to figure out where is the error. And he found that there is an index which is shift off by 1. So he's modifying again the spider and running it again. And now I think he's got everything. So you see, I didn't touch any line of code myself. I didn't write, I didn't correct, I didn't go to the website. The MCP server handled all the iterations. And the LLM at the end figure out what to change automatically. So that's something that can be clearly included in the web scraping copilots. So you can find this MCP server on my GitHub if you'd like. So feel free to try out. Good? Yeah? No, it's not finished. I have to conclude. So point for the bot. So let's wrap up, at least. So first, to build a complete production-ready scraping stack, you need massive investment. So you need custom browser, you need consistent network stack, clean IP address, and a specialized team of experts. So we are talking about serious money here. So if you're starting a business, clearly, if you want to gather data at scale, that initial investment is becoming impossible. So only a few major actors in the industry can maintain this level of infrastructures. So we have big scraping company, we have data aggregator, and AI company like OpenAI or Perplexity. Second, we are moving towards something kind of a closed internet. So data company understands that AI provider are making huge progress accessing their website for money. And instead of playing endless cat and mouse game and trying to block them, they try a different approach. They want to make deals and building authentication systems. So the future is pretty clear. We have major websites which will be accessible for AI agents, but everyone else will be locked out. So yeah, the barrier of the entry is getting higher and higher every year. So let's see what 2026 brings us. Thank you.